Okay, well that is background. We can do a little experiment to make a cloud. I've got a vacuum pump hidden under here and a little gray chamber that I'm going to evacuate. I'm going to hook this up to the jar in this way, and then by twisting a valve, I'm going to allow some of the air from this jug to pass into this evacuated cylinder. When I do that, let's say for the sake of argument that I take about that much of the air from here on up and suddenly remove it. Well, then the rest of the air in the jug is going to expand to fill the jug. Now, what happens when air expands suddenly? We've been over and over this, but now you're going to see it in this new context. When air expands, it does work on its environment, and it adiabatically cools. Its temperature drops because of that work it's done in expansion. When the temperature drops, the saturation vapor pressure drops as well. That is, the amount of water vapor that can be held in the vapor state suddenly decreases. Well, if this is the saturation vapor pressure, and this is the amount of water vapor that I actually have, the partial pressure of water vapor, and I suddenly drop the temperature, that's going to drop this value down. I haven't changed the amount of water in the air, but I've decreased the amount that can be held in the vapor state. And if I move it down to this level and slightly beyond, that excess must suddenly condense. It cannot remain in the vapor state. And therefore, I'm going to force a cloud to form in very much the same way that the atmosphere does, by adiabatic expansion. The only difference is, instead of getting the adiabatic expansion by lifting a parcel up into the atmosphere, I'm doing it with this little apparatus of suddenly dropping the pressure. Are there questions on this? Now, I'm going to give it a few condensation nuclei because I'd prefer to form a large number of small droplets rather than a small number of large droplets. It'll make the cloud more visible that way. So I'm just going to blow a little bit of smoke in there. You won't be able to see this, but these will be very tiny. These will be very tiny aerosol particles just to give the water something to condense onto. What you hear is a vacuum pump. I have a little gauge here to tell me whether or not it's working, whether this chamber is being evacuated. I've put it on this overhead projector to get nice illumination of the chamber, and you see it's empty now. There's nothing there. Okay, I think we have a little bit of a vacuum in here, so I'm going to try suddenly opening of, right now this valve is closed, so there's low pressure here, but normal atmospheric pressure in the jar. But when I open that valve, some of the air is going to be sucked off, and we'll see. This doesn't always work, but we'll see if we can form a cloud this morning. Three, 2, 1. There is a cloud. Now this is a reversible process where I suddenly, to bring that parcel back down in the atmosphere, or here just let the pressure build up, it would compress, warm, and remove the cloud. So on the count of 3, I'm just going to rip the top out of there and let atmospheric pressure push that down again. 3, 2, 1.